First, let's take a look at the general performance of energy consumption in selected American cities, which is illustrated by a map. In this interactive map, you can see that each city is divided by postal code, and the color depth represents the average source EUI of the administration area. The pie chart of each administrative district represents the percentage of energy consumed by different types of buildings. The map is interactive. You can choose any city you want to observe. In addition, you can filter by the year and building was built. In the scatter plot in the lower left corner of this picture, you can also observe the relationship between the average source EUI and the year of construction. Overall, the average source EUI of commercial buildings is higher than that of residential buildings, and after 1900, the slope of commercial buildings was larger than that of residential buildings. That is, as the construction year increased, the energy consumption of commercial buildings increased. Taking Chicago as an example, it is easy to find the average source EUI of the zip code area where two Chicago airports are located is extremely high, while the energy consumption performance of other areas is generally good. Now, let us focus on building type in Chicago. We can easily observe the percentage of energy consumption of various types of buildings in the pie chart. When you click on a tab, the interactive map will only display the tab. For example, we can find that energy consumption of grocery store or food market buildings account for a large proportion, while the energy consumption of education buildings account for a smaller proportion. Similarly, the above conclusion can be obtained for other cities. The comprehensive and interactive map is a good display of general performance of energy consumption and provides good enlightenment for more detailed visualization results in the future. For there are too many variables related to building types and too detailed. What's more, the frequency of appearance of each type is very uneven. Some are few, some are many. In order to better explore the problem, we gather and classify buildings into 3 levels. First, we use zoom chart to show the results. Click on the second level to see the third level classification under the classification result. The arc of the fine shape represents the observations count of this type of building, and you can see the count and classification information by holding the mouse on the certain area. In addition, we also draw a tree-like classification diagram. The trunk and branches represent the classification relationship. Now we want to explore the relationship between the energy performance of buildings of different construction years and the building area. Scatter point of the sky map contains all the observations. The latitude represents the energy level, the longitude represents the year of construction. The different color represents the building type, and the radius of the circle represents the building area. If you want to view the detailed information of a certain point, click it, and there could be ID, building area, building type, and the city to which it belongs. For example, we noticed that the bright green building in the 1848 is an old building but has a high energy star rate. Click it and take a look. It's an educational building in Philadelphia. After the general analysis on the energy consumption of buildings, we dive into the various facility type of buildings, which we think that more reasonable when people want to compare different buildings in respect to their performances on energy consumption and energy saving. We choose radar chart to show how different types of buildings perform in their energy consumption. The facility type are represented by a sequence of equal angular spokes. Here we have 14 types after aggregation on the original datasets. The length from a circle on the spoke to the center represents the average value of sites or source energy use intensity, that is EUI, of the specific type of buildings. And smooth lines are drawn connecting the values of site or source EUI separately. For each spoke and distinguished by different colors, red represents site EUI and green represents source EUI. Then we draw scatter plots and box plots with filter options. The scatter chart supports the selection of any 2 numerical variables at the horizontal and vertical axis. And different colors can be used to indicate the performance of the observed values in different classification situations. In addition, we have also drawn box plots, which supports the selection of any relationship between the character variables and numerical variables. No matter which variables you want to explore, you want to choose, these 2 graphs can match your needs and very convenient. This is an advanced scatter plot. We call it a star plot. The fuel energy consumption and electricity energy consumption of all observation points are decided. Because the fuel situation is not directly displayed in the data, we calculate the fuel energy consumption through formulas. The abscissas and ordinates are fuel EUI and electricity EUI. We use color and brightness to intuitively display these values. The higher the fuel EUI value, the redder the color it also means hotter. The higher the electricity EUI, the higher the brightness of the color. Such representation design also match our real life. In general, the more electricity is consumed by building, the more fuel EUI is consumed. In addition to discussing building energy in the United States, we also made other interesting attempts on our project. We made funny animations of a blog photo by using JavaScript.